And that's video number 3, on which we're going to talk about the impact on the environment from our freshwater consumption. As mentioned, potentially the main issue about our freshwater consumption is in that 70% of the freshwater goes to irrigation. It's leading to problems that we already talked in agriculture about soil pollution and salination, the fertility loss of some soil, the water pollution and waste also of water. And that is linked, in particular, this is increased little more and more, sorry, by the fact that there is an increasing stress of water access in the world to meet our need. And if we look, every countries in the world tend to spend at least 70% of their water consumption for irrigation, which is in blue. As you can see right here, we have irrigation, livestock, domestic use, manufacturing, and electric. In all of the countries, most of the fresh water consumption is in fact used for irrigation. Then after, in between the other ones, there are differences, but we can see that irrigation should be a way, at least, where we can make a big change in our freshwater use and try to save some of that freshwater use. Let's look at what happened in California, because California is a specific state with a heavy population, but most of the population living in South California, which is more arid than the North of California. To kind of give access to the people of the population of the South California, the state has built two major projects. They have created the State Water Project, which in fact is a long aqueduct that moved water from the North California toward the south, and you can cross this aqueduct every time you go toward the coast. It is a huge aqueduct moving water all year long toward the south of California, and to provide water for the valley, the Central Valley, for its agriculture, heavy, intense agriculture. The state has developed the Central Valley Project that has developed lots of canals, small aqueducts, deltas, to move the water that comes from the mountains in general inside of the different crops of the Sierra Nevada. You have a picture, sorry, you have a picture of the aqueduct of the State Water Project right there, and a quick movie on those projects.
Now, with a reliable water supply, the Central Valley.
Oh, sorry, I forgot that. In fact, my bad. I let you watch this little documentary in the CAT Courses webpage. I forgot that I wanted to make this video short. So you'll have that video available on the CAT Courses page of this lecture, okay? And it's explaining you, in fact, about the purpose of those projects. Not so far from us, we have another study case we can look at. It's a Colorado River. And again, I will not play the video. I'll invite you to watch that video to have a better understanding of this issue. But the Colorado River is in fact a long river that is crossing 5 states inside of the most arid region of the western side of the US that is trying to grow crops and has also some industries. The problem is, by crossing 5 states who has all production happening, the Colorado River doesn't have enough water anymore, and it's being over-appropriated. This is the amount of run of the river, and this is a demand on that river. You have different states demanding water, especially California, you see a big portion. You have other states right here, and then Native American also in right of asking access to water. But unfortunately, because it's over-appropriated, there is more demand than what it happened. The Colorado River mostly reach the Pacific Ocean dry. It doesn't have the chance to bring water anymore to the Pacific because it has been, the water has been used all along the stream. So this is also a big issue. And again, I invite you to watch that video. Going back to California, I mean, we were not so far with the Colorado River since California was still using it. Since we don't have access to enough water for our crop production in particular, there is a huge stress in the Central Valley, as we can see, for the agricultural production that we have. Well, we have turned into taking water from the groundwater, from the water that is found below our feet. Water is found between soils, and it's not like big pools, but it's really if you place a pipe and you start pumping, you will be able to get access to that water. So we've been doing that in California to provide water to our crops. This groundwater is, in fact, if we look at the cross section, this is imagine the valley with the river, we'll have a zone that is called the unsaturated zone. So when you build your well and place your pipe, you want to go above that zone because this is a place where you have a mix of air and water. So you're not able to pump enough water at this point. You have to cross what we call the water table, which is where you start having all of your ground filled up with water. And as soon as you're below the water table, you're inside of what we call the saturated zone. So all of the small space between the grain of your soil will be occupied by water. Above the water table, it's occupied by air mostly and a bit of water. But below the water table, the saturated zone, all the space between grains will be filled up with water. So we have found the perfect solution. We're using the groundwater to feed our crops, additionally to the water that comes from rain and the mountain itself. But the downside of that is that we've been pumping too much, faster than it can be recharged. Remember the reason, the time that water molecules spend over the different reservoir? Well, for groundwater, it's one of the longest one. It takes thousands of years usually for for molecules of water to move there. So we're pumping way faster that it can replenish. And so we're doing what we call a groundwater overdraft, meaning that we are pumping more than the capacity of discharging. That happened a lot in California, majorly in the mid-US with a big aquifer. Aquifer is another term for groundwater that is called the Ogallala Aquifer, and they use a huge impact right here, a huge risk of depleting the water available for them. Another issue is by taking more water than it can recharge, your soil is becoming weaker. It has less chance of resisting to the pressure, and we obtain what we call a land subsidence, meaning that the ground goes down, and it goes down, and it goes down. And that will be illustrated
This morning,
in this
California
video
is
I'd like you
facing
to
a
watch.
different kind of emergency. The state's water crisis is impacting one of the world's most important farming regions, the San Joaquin Valley. The ground is literally sinking by up to 1 foot a year. Ben Tracy shows us how the land is becoming as unstable as the water supply.
Every 6 weeks, Michelle Sneed visits this white shed. She checks the pulley system and records a measurement. The numbers show that the ground beneath her feet is sinking.
We're measuring the highest rates we've ever measured here, among the highest rates ever measured in the entire world.
Sneed is a government hydrologist and says parts of California's Central Valley are dropping by 1 foot each year. Some areas are 10 feet lower than they used to be.
We would have had many, many feet of dirt above our heads right now.
That's right, that's right. We'd be standing 10 feet higher than we're standing right now.
This is why the ground is collapsing. California's farmers are pumping groundwater as fast as they can in order to keep their crops alive during a drought that has left them high and very dry. But when this much water is pumped out of the aquifer below ground, the clay between the pockets of water collapses and the ground starts to deflate like a leaky air mattress. The sinking is buckling the walls of irrigation canals, damaging pipes, creating giant sinkholes, and cracking homes. This bridge has dropped so much, the water will soon flow over it instead of under it. Fixing the damage could cost more than 100 million tax dollars.
You just have to keep going deeper and deeper.
Steve Arthur is a well driller. Some wells are now 2,500 feet deep. That's 2 Empire State Buildings underground. Water that deep is thousands of years old. But it's desperately needed because more than half of the country's fruits, vegetables, and nuts are grown here.
You tell this farmer he can't drill any more wells, he can't farm as many acres. You're going to go into the store and buy a gallon of milk for $10, a loaf of bread for $5. Then the public's going to say, hey, what happened?
So we see this progression from green to yellow to red as the state is literally drying out.
NASA's senior water scientist Jay Familietti uses satellite data to show the depletion of California's water resources. The state has lost 16 trillion gallons in the past 4 years. That's enough to fill Lake Mead, the largest reservoir in the country, twice.
So what happens when the water is simply gone?
That's a question that all of us, first of all, have a difficult time really fathoming. If we still want to have agriculture, we have to come up with the water from some other place.
But for now, the drilling continues, even with the ground all around it caving in. For CBS This Morning, Ben Tracy, California's Central Valley.
16 trillion gallons.
I know. You know, Steve Arthur, the guy from the drilling company, makes a good point. $10 for milk and $5 for bread, that will get your attention.
And the irony of all this is there's so much water, you know.
All right, and with that, so definitely this is happening. You see the surface of the ground was this high in 1965, 2013. It's this below. So it has lost in about 40 and something years, 7 feet of elevation. And that has, we observe this happening differently in the Central Valley because the groundwater is not used the same way. And also the time of, the amount of water going into it is not the same way. We observe a difference between the Sacramento Valley and the north part of the valley, of the Central Valley, versus the San Joaquin Valley, which is where Merced is, versus the Tulare Basin, which is around Bakersfield. Of course, the Sacramento Valley receives more water in terms of precipitation than San Joaquin Basin, than even the Tulare Basin. The Tulare Basin and south of the Central Valley receive less precipitation. So indirectly, there is more demand of water for the crops. So we're pumping more groundwater from the Tulare Basin than the San Joaquin and even than from the Sacramento Valley. And so we have observed that the groundwater in the Central Valley in general is decreasing, depleting, going down, but that has happened more in the Tulare Basin. As you can see, it's pretty deep. A bit less in the San Joaquin, there is a constant decrease, however, and in the Sacramento Valley, it's happening, but very slightly. Again, because of the difference in precipitation in both that allows the Sacramento Valley to use more of the runoff water for the agriculture than the San Joaquin and the Tulare Basin, and the aridity between those three regions. And so the Tulare Basin, the south of the Central Valley, is definitely overdrafting the amount of water available to it. So that's another issue about our misuse of water related to our agriculture. Then, in terms of us, people, we can make changes. That was a couple of years, and I've seen some improvement happening in the irrigation of our landscaping. But you can see the irrigation of those happening during daytime, when it's supposed to happen either at the beginning of the morning or later in the evening, when there is less risk of evaporation. So all of those mispractice of irrigating during day when there is a high chance of evaporation is bad. Also, this over irrigation where you have pools of water happening, it's not a good idea. Then another change is we need to stop using plastic bottle. And I'm always amazed when I'm doing my shopping to see, especially in Costco, so many people buying plastic bottle. I cannot understand why not placing a water filter system, which costs a little bit more at the beginning, but over the time, it will be cheaper than buying plastic bottle over and over, which lead at least to a lot of pollution, that because unfortunately a lot of plastic bottles are found everywhere in nature, and it needs to make 1 gallon of bottle of water, you need 3 virtual gallons of water. So there is a huge consumption of fresh water, useless in some way, consumption of fresh water to create this plastic bottle. Also, instead of using plastic bottle, let's use reusable bottle. And I know that it's one thing that you as a student of UC Merced are doing, and it's pretty good. But plastic bottle is really bad for the environment. And that's something that by doing this, you're allowing to use less fresh water and you're avoiding to create additional pollution. So it's kind of a double effect just by changing that. Final thing, the effect of climate change will not help on our consumption of water. It's expecting that the drought will increase with the climate change happening now and in the future. The amount of precipitation might be about the same. It might happen more in the stormy weather, meaning that we will receive a lot of precipitation that will not be stored instead of long days of precipitation. Then the glaciers are shrinking, we're losing the excess of fresh water from the mountains. The snow melt is happening faster. So we did have a lot of snow over this year, for example, but the snow melt happened earlier in the season. And instead of providing water during all summer long, it's only providing water during the beginning of the summer. And then after we have to turn into groundwater for the excess of fresh water. And the climate change will definitely exacerbate, make worse all of the stress, all of the lack of availability of water in most of the country. And you see that this is what we estimate to be the change of water availability. As it goes to orange, it means less and less water being available. And by 2050, about 2/3 of the region of the world will have less access to fresh water than they have right now. So there will be issues happening even more in the future. So we need to look at some solution. And for that, I invite you to join me into the video number 4. So we'll stop there and let's meet for the last video of this lecture.